Alright, welcome to 6.4, elimination using multiplication. So last time, you guys, we eliminated using addition and subtraction. Today, we're still going to be doing some of that addition and subtraction, but we're adding one element, and that is multiplication. The reason that we need to add in this element is because sometimes things don't line up. Okay, so sometimes I might have something like 3x in one equation and a 6x in the other equation. If I'm trying to eliminate those, those have to match up, right? So what I can do is I can actually multiply the whole equation, because this will probably have some other stuff in here, right? I can multiply this whole equation by 2 to get, and it won't change the value because I'm multiplying every single piece by 2. If I do that, I can get the 3 to turn into a 6 so that I can eliminate. So that's really the process for today. Okay, so some steps to elimination. I don't love these steps. I wouldn't put these down word for word into my notes or anything. But the first step is to multiply at least one equation by a constant to get two equations that contain either the same term or the same term with opposite signs. So I don't like how they said the opposite terms. Meaning, if you have a 4x and you want to get a 4x in the other one, the other equation, you'd multiply it by something to get you a 4x or a negative 4x. That's what it's trying to say. You just want the coefficient, the number that's in front of that, whatever that term is, the x term or the y term, to be the same. Then what you could do is you could either add or subtract. So add, I'm going to add something here, or subtract the two equations to eliminate a variable. Then solve the equation. Okay, so we're going to now substitute whatever we get. So if we're solving for y, we get a y value, we plug it back in, we substitute it back in to one of the equations, and that'll give us our other variable. Sounds confusing, right? Well, let's do one because it's not as bad as you might think. Oops, sorry about that. So here we go. For example 1, what we'd have to do here, okay, what I like to do for these is I like to look for something that is easy to get a commonality. If there's a common factor in two pieces, it makes it a lot easier. So if I'm looking at this, 3 and 6, it's very easy for me to change this 3 and make it a 6. How I would do that is just multiply it by 2, right? So that's what I'm going to do, but you could choose anything you want. In fact, you can multiply both equations to get something to line up as well if there's no common factor. For instance, just to show you this, and I'll get to this later in the lesson, I think, but since this is a 2 and a 7 here, if I wanted to get an elimination for the y's, I'd actually have to multiply both of those. Because probably, 14 is a number that both go into, so I can multiply this one by 7, or I can multiply this one by 2, not or, but it would be an and. You'd have to multiply both to get those y's to line up. Okay, so for now, since we're just first learning this, they're going to make it easy on us. They're going to give us something with a common factor, or a common multiple, I should say. So what I'll do is I'm going to multiply that bottom equation by 2, but I'm going to keep the first equation the same. 6x minus 2y is equal to 10. And now for the second equation, I'm going to multiply everything by 2. So 6x minus 14y equals negative 38. That's just this equation times 2. Okay, now that I have that, I notice that my 6's are the same, which is what I was looking for. Okay, and in order to eliminate them, I have to subtract them. Okay, so I'm going to subtract the two equations. 6 minus 6 is just 0. Negative 2 minus negative 14 is negative 2 plus 14, which is 12y. Okay, and then 10 minus negative 38 is positive 48. Divide both sides by 12, and I get y is equal to 4. So notice, once you do that, it's the same exact process from last time, the last lesson. Okay, the only new thing is just that multiplication piece. Now I'm going to take that y and plug it back into either one of these. I'll choose the first one, so 6x minus 2 times 4 equals 10. Again, I chose the first equation, plugged the 4 in for y. And then 6x, that's 6x minus 8 equals 10. So 6x equals 18, because I add 8 to both sides. Divide both sides by 6, and I have x is equal to 3. So 3 comma 4 is the solution to this system, for example, 1a. 1b, for this one, there's a common factor in both r and q. So notice I can multiply this equation by 3 to get the 9r's to match up, or I can multiply this equation by 2 to get the 2q's to match up. So that's, I think, what I'm going to do. Okay, so if I do that, I get 18r plus 2q equals 26. Notice I just multiplied everything by 2. And the reason I did that, for the second equation, I'm going to keep it the same. 3r plus 2q equals -4. This is the reason I multiplied everything in the first equation by 2. I want those things to line up. Okay, so now that they line up, I'm going to subtract. The reason I'm subtracting is because my signs were the same. 2 minus 2 is 0. That goes away. Okay, 18r minus 3r gives me 15r. 26 minus -4 gives me 30, because it's 26 plus 4. Divide both sides by 15. R is then equal to 2. Okay, I'm going to take that, I'm going to plug it back in to either equation. I guess I'll choose the first equation. So 9 times 2 plus q equals 13. That's 18 plus q is equal to 13. Subtract 18 from both sides, and I get q is equal to -5. So final answer, q comes before r in the alphabet, so I'm going to choose that as my first coordinate, although it doesn't really matter, but if it's an x and a y, make sure the x comes first. By convention, I usually say that whatever comes first in the alphabet, we go with first. So I'm going to say -5, 2 is the answer to this. In the back of the book, if it's not an xy pair and they're reversed from your answer, don't worry about that. I will always count that correct. But by convention, try to keep it straight that whatever comes first in the alphabet should be the first thing that comes here on your coordinate. Okay. Now, here is one of those examples where I was talking about earlier where you might have to multiply both equations to eliminate. Okay, so notice there's nothing in common with 3 and 4 and 2 and 3 there. There's no common factor. So what I want to do is, the easiest way to do this, you guys, is to multiply, if we multiplied the two together, okay, that has to be a common each of these pieces would have to be a common factor of that thing. So if I said, I want to eliminate, in this case, since they're smaller numbers, I'm going to eliminate y. If I want to eliminate y, the number that 2 and 3 both go into is whatever 2 times 3 is. So 2 times 3 is 6. Okay, so I want my y's to be 6. Okay, how do I get 2y to turn into 6? I got to multiply it by 3. So I can multiply this equation by 3. But in order to get a 6 on the second equation, how do I get 3y to turn into 6? I got to multiply that one by 2. Okay, so now we're applying the principle twice, right? So if I multiply the first equation by 3, I get 12x plus 6y is equal to 24. And if I multiply the second equation by 2, I get 6x plus 6y is equal to 18. Now I'm going to subtract because my signs are the same. Okay, so if I subtract here, I get 12 minus 6 is 6x. 6 minus 6 is nothing. 24 minus 18 is equal to 6. Divide both sides by 6, and x is equal to 1. Okay, plug that back in like every other time. So we have 4 times 1 plus 2y equals 8. You can plug it into the other one as well. It does not matter. You'll get the same answer. 4 plus 2y is equal to 8. Subtract 4 from both sides. We get 2y is equal to 4. Divide both sides by 2. We get y is equal to 2. So the correct answer here would be 1, 2. That is the solution that works in both of those equations. Okay, so example 2, I want you to maybe try this one out on your own. Maybe I'll help you guys set this one up. So this is 2a. I like these two pieces because they're just slightly smaller than the other two. So what I would do to eliminate those is multiply them together. 5 times 2 is equal to 10. Okay, if I do that, it makes the multiplication piece really easy. Okay, because if you notice the pattern, if you do that, you would multiply the first equation by whatever this number is and multiply the second equation by whatever that number is, right? But anyway, we're trying to get 10, so multiply this one by 2, this one by 5. If I do that, I get 10x minus 6y equals 12. And then for the second equation, I get 10x plus 25y equals negative 50. Okay, I'm going to subtract because the signs are the same. When I subtract, this goes away. Negative 6 minus 25 gives me negative 6 minus 25 gives me negative 31, I believe, y. And then 12 minus negative 50 is actually positive 62. Divide both sides by negative 31. I get y is equal to negative 2. Okay, now I can take that, plug it back in. So I'll plug it back into the first one for fun. 5x minus 3 times negative 2 equals 6. Okay, that's 5x plus 6. Negative 3 times negative 2 is positive 6 equals 6. Subtract 6 from both sides, I get 5x is equal to 0, which means x must equal 0. Okay, so final answer, 0 comma negative 2. Let's do one more like this. Here's this one. Let's try to get rid of the b's. Okay, so to do that, I need a common factor. 3 times 2 equals 6, so that is the common. I'm going to multiply this one by 3, multiply this one by 2. Okay, when I do that, I get 18a plus 6b equals 6. And on the bottom one, I get 8a plus 6b equals 16. Subtract these, and I get 18 minus 8 is 10a. 6 minus 6 is just nothing. 6 minus 16 is negative 10. Divide both sides by 10, and I get a is equal to negative 1. Plug that back in. Okay, 4 times negative 1 plus 3b equals 8. That's negative 4 plus 3b is equal to 8. So 3b is equal to, if I add 4 to both sides, 12. Divide both sides by 3, and I get b is equal to 4.